All right, so here's what you're going to learn in this video. This first question, why did you create a new language? This is from the Golang FAQ. This is a great thing to learn. And then here are the takeaways. You can see them on the screen. We're going to learn about functions, and modularity, and parameters and arguments, and the syntax of functions, func, receiver, identifier, parameters, returns. Those are optional, both of them, code block. And we're going to learn why we should not use named returns in the Go programming language. We're going to learn about variadic parameters, variadic arguments, and unfurling a slice. That's my word. I've found no other better word. So I'm coining that word for use in this situation, that phrase right here. I'm coining it, unfurling a slice. I've actually been using it for close to a decade. Multiple returns and the blank identifier. Going to learn about all that. Anonymous functions. We're going to learn about closures. I'm going to put those on 2 lines when I fix this. Functions are a type. You're going to learn about that, how you can use functions as parameters, arguments, and returns. And we're going to learn about type error and error checking and defer and panic and syntactic sugar. All of that in this video. And then just to show you the code we're going to look at so you can get a sense of whether or not this is going to be worth your time. That's not the code. That's the code from the previous video. Here's the code we're going to look at. And the code is, look at this, so fun, syntactic sugar. Love those package names. So here's the code. And the code is, I'm going to just stretch this out a little bit, make it bigger. There we go. So we're going to see defer and then a basic function and then just doing a basic return and then doing returning 2 values from a function and multiple returns, and then doing a parameter, and then doing 2 parameters, and then doing a variadic argument, and then unfurling a slice, and we'll do an anonymous func, and then here's another anonymous func, and yet one more anonymous func, and so we'll see kind of how to make all that happen. And then we're going to look at closure. We'll see closure in action. Then we'll take a look at methods. I didn't add that into the course outline. I need to add that in. And then after methods, we're going to take a look at sequential execution and just kind of see that, and then multiple returns and syntactic sugar. And so for the multiple returns, we're going to see this code right here. So you can pause the video and take a look at that. And then for syntactic sugar, we're going to see this code right there. And so you can take a look at that. So we're going to learn all of this. And this is all detailed, right? So if you're in a rush, you only have so much time. This is all detailed in this README here. And so this README has like a lot of great stuff that you could read about. It's all this stuff here, including Hachiko. And I'm not sure I'm pronouncing that right, but Hachiko waited. So when I was thinking of the defer functions and how they wait, I thought of Hachiko in Japan, and Hachiko is a dog. And so this is a dog. You can read the story right there. You could pause it. But I actually had the opportunity to go to Japan at one point, and I saw this statue in person. And it's a touching story, so you can pause the video and you can read about it right there. But that's Hachiko. And so thinking about the defer function in Go made me think of Hachiko. So we're going to see all that. And to get to this README right here, you go to GitHub, goes to 11, Learn to Code Go version 3, and then go into the 000 BRBK Go Tour folder. And when you come in here, you'll find the root README, which has links to all the other READMEs, and this is the one we're in. And then we're working through the Ultimate Go Tour here. And the Ultimate Go Tour is at tour.ardenlabs.com/tour/list. And we've gone through the welcome, the variables, the struct types, the pointers, constants, and now we're going into functions. And so we're going to do this, and then in the video after this, we'll do the exercise together. So that's what's coming. Let's get to it. So the first thing I want to point out here is just this opening quote. I like opening these READMEs with just something which is kind of interesting. And so this is super interesting and also super relevant and super important to the Go programming language. And so Go, the Go programming language, Golang, they have an FAQ. And in that FAQ, there's this great question, why did you create a new language? And the answer to that is right here. And the primary takeaway from this, and this is something that anybody who is working in the Go programming language should know, the primary takeaway is that they wanted to create a language that had efficient compilation so that you weren't sitting around forever waiting for your program to compile, but you could compile it quickly, test it, compile it quickly, test it. And it had efficient execution, so it was really performant. And it could perform really well at scale in a cloud environment with multiple cores. And then also it had ease of programming, right? So you could easily program in the language. So that's just like the first thing, which is like good to know, right, about Go. And so you could read that right there. So next thing we're going to talk about is functions. We're going to talk about functions. And so here's a little overview of functions. And functions allow us to encapsulate and organize code for better modularity and reusability, right? So it allows us to take our code and put it into little chunks, into little functions, and encapsulate the code into a little chunk, a little function, and then that allows us to reuse that function, so we have reusability. And it's modularity because it puts it into like, that function could also be thought of as like a little module. Let's run this module, let's run that module. And so that was like an innovation in programming computers at one point, because originally computers were written with spaghetti code. So you just have one long document, with a whole bunch of code on it. It'd be one long document, and that would be your code for a program. And you'd have all these go-to statements on that document. And so you'd be like, hey, if this happens, go to this line in the document. If this happens, go to that line in the document. And that was really hard. It was really convoluted to follow the logic. And they called that spaghetti code. And so modularizing our code, breaking it up into little chunks, little modules, right, little function, encapsulating our code into some sort of little function, allowed us to more easily organize code and understand it, and then also reuse it. And so there's this principle in programming, dry, do not repeat yourself, right? So writing a piece of code once that's going to do something, if we have to fix that, right, we only have to fix it in one place. We don't have to go find like all the different places we have that piece of code that we've rewritten many different times. We write it once, and if it needs fixing, we fix it once. And so that's like what functions are for. And then function declaration, I think that's the next thing we're talking about here. Sweet. So function declaration in Go, I have this little note in our README, so I guess I'm going to go here and take a look at it because I want to show it to you. So I just need to click on that and bring up the index for us once again. And so here we're at the index, and if I go into the functions type, synonymous function closure, and come in here, what I wanted to show you here was the syntax for a function. And so here's the syntax for a function. So I'm just going to copy this, Command C, and then come over here to my editor. And in my editor, I have this live folder right there, and I'm going to put this in as a comment. And so when we create a function, I'll actually do this down below because I'll create my function down here. But we create our function, and it starts with the func keyword. And then if we wanted to attach this to a type as a method, we would put in a receiver right there. And so like if I had a type here, and if this type was user, and it's the underlying type is a struct, and user has a field first for their first name, and it's going to store a value of type string. So if I have that, right, I could then attach this function to that type, and anytime I have a value of that type, right, this function then becomes a method. So that's the receiver. I just want to introduce you to it here briefly, like as we're looking at the overall syntax for a function: func, receiver, identifier, parameters, return, code block, right? Like those are the elements that go together to make a function. And so if that's new to you, it can take a little bit of time to wrap your head around. But if you just like post this on your desk, you'll remember the order of things. And so that could be super helpful. But right now we're not going to do a method, so we're not going to have a receiver. And we will have an identifier, so we'll call this, foo. And so foo and bar are often, foo and bar are often variable names that are used in programming, and you could Google that. And so they're used often just for, for example code, for examples. And so I often thought, just a little anecdote, I often thought that'd be a really cool bar, like in, I don't know, Silicon Valley, you could have the foo bar, and then right next to it, you could have the restaurant, the stack and the heap. I think that'd be totally sweet. So if anybody's watching this who's already like iPod and made your billions, foo bar and stack and heap right next to it. All right, so there's foo, and then we have, right after foo, we're going to have where we'd put parameters. And so we could put parameters in here, and parameters, when you define a function, parameters are, you're saying, hey, these are the things I'm going to pass into the function. And so I could say, hey, I want to pass in here a value of type int. And so that's a parameter. And then when I call the function, I pass an argument into the function, right? And so just to illustrate that, so we have foo, we have func foo, and so func is the keyword. We're not doing a receiver. We have the identifier of foo. We have one parameter, right? And that parameter is going to be an int, some value of type int. And you'll notice that here I have square brackets around parameters. So you could put multiple parameters here. If I wanted to, I could also say, hey, you know, let's have another parameter come in and have it be a string, right? So you put in your parameters. I know this is totally rudimentary. We're going to get to more advanced stuff, but if people are just starting out, I want to make sure all this is covered because a lot of times people need the basics, right? And so we have foo x and of type int and y of type string. And so those are the parameters. And I'm not going to have parameters right now because we're just doing a basic example. I'm just going to show you the bare bones basics. So we have the identifier, we have the func keyword, we have the identifier. We're not passing in any parameters. And then right after this, if I wanted to return something, I could return an int. If I wanted to return multiple things, I put in parentheses like this, and I could say, hey, I'm going to return an int, a string, and an error, right? I could return all of that. And then those would be returns that I could receive when I called the function. And then after that, I have my code block, right? And so I'm going to just print this. This function is just going to say my first func, right? So there's my first func. And I'm going to save this. And that's my first function. And then to call my function, so you create your function, and when you're ready to use your function, you call your function, and you put parentheses after it. So function, when you call it, always has to have parentheses after it. And we're going to see this when we look at anonymous functions, that, you know, we could create an anonymous function, and then we'll put the parentheses after it. And the parentheses after it can kind of seem like, what are those things doing there? But, well, you created an anonymous function, now you're going to call it, so you got to put parentheses after it. And if we were to pass an argument into this, so if this was taking an argument, so this is going to take an argument like an int, right? If I was going to pass an argument into it, that's where we'd pass the argument into it. So this is a parameter. When we define our function, just so you're clear on the terminology, that's a parameter. And then this is an argument that we'd pass into it. But again, we're keeping things simple here, so we're not going to pass an argument in, and we're not defining our function with a parameter. But to call foo, I still need to have those curly braces where if I was passing an argument in, I would put them in there. And so that's everything I need to do to run my first function. And I'm going to bring up my terminal over here, and then I'm going to cd into, what am I in, 01 live? I'm in 00 live. So I'm going to cd into 00 live, and I'm going to do go run main.go. And you can see my first func ran, and that's my first func. And so that's just to illustrate the basics of a function. We're going to pick up the speed here a little bit, and I'm going to look at my notes, and I'll be right back, and we'll go into looking at this code here. I think that's what we're going to do next, but I'm going to pause here for a second and figure out what to say next. See you in a moment. All right, so now we're going to take a look at these different things we could do with functions. And here we have the syntax. We just saw that. But this one here is we could use this defer keyword, and defer will defer this function until the function that contains it is over. And so when this function main is ending, when it's at the end, the very last thing main's going to do is it's going to run all of the deferred functions. So if I defer this function Hachiko, right, and Hachiko is that dog that waited, this function, that's why I named it Hachiko, right? This function here is going to wait until main has done everything it's going to do, and main goes all the way down to right here. And so when main is done, when it's done everything, it's like, okay, I've done this last thing, right? And code in a computer, control flow, this is called control flow. So control flow in a computer program goes sequentially, right? Sequentially means it starts right here. In a Go program, it starts in package main, and then it goes into func main, and it starts in func main, and sequentially from top to bottom starts going through the code, right? So control flow in a computer could be sequential, it could be conditional, like some sort of an if statement, and can be iterative, like a loop. So that's control flow. So when we go through the control flow of main function, it's going to go through all this right here, it's going to come down here, it's going to run through this. When it gets done with running, run sugar, from right there, the last thing it's going to do is it's going to run the deferred functions. There could be multiple deferred functions, and so Hachiko will run last. And so the code for Hachiko down here is fumpt println, I waited, woof woof, right? Like that's the last one that's going to run. And if I run main.go here, you'll see the very last thing that it does, I got to come up out of live, and the very last thing that it does is it's going to run that deferred function. And so right there, right, the last thing it ran, even though sequentially in the order of things it hit this first, it deferred it and it waited till the end, and then it ran that one last. And if we look at the code on that one, just so you could see, like, okay, what is Haichiko doing? Haichiko has just got the keyword func, and then it has an identifier, and then it has the parameters, and it doesn't have any parameters, and then it has its code block, and what it does is it prints out this right here, and you can see that printing out right there. So the next function we're going to look at here is just the basic function hello. And so we saw this in the previous little part of the video where I created a function, but it's also just like Haichiko, and so that's how hello works. And you can see hello is printing out right here. That's the first one that prints out hello gophers right out there. That's the basic hello. And then I'm going to call this one hello gophers 2, and I'm going to call this one hello gophers 3, just so we could see that. And this function here introduces us to a return. So I'm going to clear out everything over here, Command K. And you can see here I have my func keyword, the identifier, the keyword func, the identifier, no parameters. I'm returning a string. And the string I'm returning is it's returning this string right here, hello gophers 2. So when I call this function here, hello2, so I'm going to come up here and look at how do I call hello2. I call hello2, I put the parentheses after it, and then here's s2, and func print line s2, and it prints that out. And so what that looks like here is like that, hello gophers 2, right? And then the next one is this one here, and it has multiple returns. And so we're returning another string and an int. And so when this one prints out, we get hello gophers 3, and then also 42. And so to see what multiple returns look like, we're looking at number 3 here. So I'm going to scroll down to where my functions are defined, and I'm going to look at number 3 right here. And I have returns, func hello 3. It's returning a string and an int. And so my returns are, I return this string right here, and then I put a comma, and I return my int. And that's how we get this to print out right there. So that's function number 3. And now we're going to look at number 4, where we take in a parameter. And so my func keyword, my identifier, and here I'm defining it with a parameter. And so this parameter is going to have a variable fn, right? It's going to have an identifier fn. It's going to store a value of type string. So that's the parameter. And then it's going to take hello, and it's going to concatenate with hello fn and make that hello Jenny. And I'm going to put a little space in there right there. And then it'll return that string. And so this is number 4. It's taking in a single parameter, and it's returning one value. And so number 4 here, when I call it, I give it a string as an argument. It returns a string, and then I'm printing that string out, and I get hello Jenny. And just to see it with that space, I'm going to run this once again, and I've added that space in right there. So that's a function with a parameter. And then here's a function that takes in 2 parameters, 41 and 1, right? So it takes in 2 ints. And when I run this one, I get that value stored to P5, and I print P5, and 41 plus 1 is 42. So if I look at how that's defined, number 5 coming down here, and we have number 5, func param 5, and we're taking in an A, which is of type int. We're taking in 2 ints, and they're both being assigned to identifiers, variables. The first one is A and the first one's B, and then we're returning an int right there. So these are our parameters, and this is the return. And you'll also see this in Go like that, A, B, and they're both int. So you'll see it like that, and that's idiomatic, right? This is less idiomatic, but when you're starting out, that's fine, right? But if this was production code, you would see it like that, okay? So that's number 5. And then here we're taking in a variadic parameter. And so here's some new notation that we haven't seen yet, talking about functions. And what this notation means is I could take variadic, like varying, any number of ints. I could take any number of ints into this function. And so this function will accept any number of ints as arguments. And so I'm going to go up and look at how this is being called. So this is number 6. I'm going to come up here and then look at number 6. Let me bring that up. And so here's number 6, and we're calling this function, and we're just passing in 41, 42, 43, 44, 45. We could pass in as many arguments as we want because it's defined with a variadic parameter. And then what this function is going to do, if we come back down and look at what that function does, number 6, right, is it takes in, and here I'm printing out variadic parameters so we could see what it does, and it takes in that variadic parameter, all those variadic parameters, and then the question is what kind of a type? What kind of a type does that become? And so here I'm using printf, formatting verbs. I'm saying show me the type and then show me the value. And I'm passing this to %t, which is the type, and this to %v, right, which is the value. And so these are formatting verbs when you're using printf. This is in the FUMPT package. And if this is foreign for you, I feel like I'm just really breaking things down at a very basic level in this video. If this is foreign for you, you could like go check out my course or watch some of the other previous videos. And maybe I think I talk about that in the previous videos in this playlist, which is linked down below. And so the type that is, when you have a variadic parameter, it creates a slice, right? And it's a slice of int, and these are the values in there, and so that's how it is. And so if I range over that slice, you know, I'm going to get the index and the value. I'm using the blank identifier. This is known as the blank identifier. And I'm saying with that blank identifier, I don't need the index, but I do want the value. And these could be whatever identifiers you want here, blank identifier and any identifier you want. I could have called this moo, right? Or bar, right? I could have called this anything, but I just called it v because I like this x, like x is a slice. And it's a slice of values, right? So here I'm ranging over a slice of values, and here's the value. Like that to me is just readable. And so then I have this total, I've declared it, short declaration operator to 0, and I'm adding to that total whatever value is. So it loops through all those values, gets out each value, adds it to the total, and then it returns the total, which is an int. And when I get that total returned, I get 215. So that's kind of cool. So that's a variadic parameter. And if we come up and we look at that code again in the next one, so we have number 6, variadic parameter, and then we have unfurling a slice. And so here I'm starting out with a slice. And we haven't looked at data structures yet. And again, if data structures are foreign to you, this series here is actually a little bit more advanced. So I'm kind of breaking things down a little bit too basic for this video, but whatever. Hopefully it's helpful to somebody. And if this is going a little bit slow for you, 2x me, right? Put it on fast. Jump to the parts where they make sense to you, and then also just have patience because there's a lot of people out there, and some people need to learn this stuff. Because at one point we all did, right? And so we'll learn about data structures coming up, but this is a slice of int, and just so you can see where we're going to learn about data structures, you know, here we're in the Ultimate Go tour, and in the Ultimate Go tour, we're looking at functions right now, but arrays and slices, so those are coming up real soon. So here I have a slice of int, and then I'm going to pass in that slice of int here, and I'm going to unfurl it. And so notice I've got the dots on the other side, and these ellipses, right? So in English literature, in writing, 3 dots is kind of like an ellipsis, and it just means an ellipsis in literature means, hey, there's more here. Like, you know, you would use an ellipsis like in a story, whereas like, you know, and then they got in the taxi, and you know, and then they got in the taxi ... like, oh, there's more to be said there. And you could just infer, you know, like there's more there. That's kind of what the ellipsis means. And so here the ellipsis means, you know, unfurl this slice, get all the stuff, get the more that's there out of there. And so what that does is it goes and takes all of these and turns them into, you know, but with the 46, 47, 48, 49, and 50 value, turns it into those individual numbers when you unfurl a slice like that, when you're passing it in as an argument. And so this is number 7. If we come down and look at number 7, there's no number 7 down here because we're calling the same function param6, right? It goes from 6 to 9. And so when we call that same function here, param6, we're passing in all those values. We get this x, which is the total, and then that total here for this next one is 240. So that's working with, that's working with a variadic parameter and also a variadic argument, and that's unfurling a slice. So the next thing we're going to look at is an anonymous func, and I'm just looking here to see where is this 8 coming from, and it looks like it's coming from right here. All right, cool. I'm just making sure I'm in the right place, and that one's anonymous. I'm going to do a little demarcation here just so I could, and we can all have our eye more easily find where we're at in the stuff on the right, right? So there's the anonymous stuff, and I'm going to come over here. It's funny. It's funny how like sometimes I slow down and my voice changes. That kind of is funny to me. All right, so here's an anonymous func. And so notice previously with all of our other functions, I'm going to come up here and just like copy this, and I'll copy that, and then Command X to grab it, and then come on back down here, y'all. And so here's our like previous deal that we had. And if I wanted to create a func, you know, I could create a func, and that func would have an identifier like bar, and then it would have whatever parameters I want to define it with, and then it would have its code block. And it has an identifier, it has a name, right? It's got a name. And so here, this function doesn't have a name, it's anonymous, there's no identifier. And so we're just saying, here's a function. And this is interesting because just like if we wanted to, we could say, oh, I'm gonna assign 42 to this variable add, right? Just like I could assign 42, I could also assign a function. And so if you look in the Go language specification, Golang spec, right? A function's a first-class citizen. That used to confuse me when I was learning program. It's like, what's that mean? They get to sit at the front of the plane, they get better snacks. Like, what's that mean? They're a first-class citizen, right? But it means that you could use a function just like you could use any other type. It's just another type in Go, and you can see all the types here. And you know, we've got bool types, numeric types, string types, and we're going to see array and slice and struct. And we've looked at pointer, and here's functions, right? And so you could pass a function in as an argument. You could have a function as a parameter, right? And you could also take a function. You could take an anonymous function, and you can assign it to a variable. Wow, right? Just like it's any other type, a value of any other type, you could assign it to a variable. We could assign 42 to this, right? Or we could assign a function to that. And so this is an anonymous function. It does not have an identifier. And this function has two parameters, right? And it's going to return a value which is of type int. And so what this does is it takes in two ints, adds those two ints together, and returns them. And we assign that to this variable add. And so now add is this function, right? And so we could call add, pass in two ints, and it's going to give us, anonymous func is what AF stands for in this situation. It's going to give us a value and stored in AF, and then we print AF out, and we get 8. We get 8, right? We get 8. Isn't that cool? And so here's another example of an anonymous func, and this is a self-executing anonymous func. And so here we have a func, it has no identifier, it's taking in no parameters, it's giving us no return, it's just printing, hey, I'm anonymous. And then immediately we're calling that function. Immediately we're calling that function, which is what those little two parens are right back there. So like just like this function here, right, we put two parens and passed in our arguments. Well, here's this function right here, and then we're putting in those parens and passing in no arguments. But that's how we call it. And so we call it and it prints out, hey, I'm anonymous, which I think is pretty fun. And so here we have one more anonymous function, and so we're just going to pass into println. We're going to pass into println this entire anonymous function right here, and then we're going to call it and give it two arguments, and then we close our curly braces there. So this is all going to run from the inside out. That's the way functions execute. They start from the inside, and then they return their value, and then another function might be wrapped around that and grab that value that the inner function, produced and returned when it executed. It'll grab that returned value that the inner function returned. It'll use that as input into its next function. And so the way I got here, right, this entire chunk of code right there, is I took all of this right here, Command Control C, and just so you could see, how you put this together. And then I'm going to say, hey, I want to printline. I want to printline, and I want to printline this function here. And let me get all that out of the way. And so I did printline, and I passed in, let me see what I just, so that's where I'm at right there. I did printline, and I passed in this function. And so I just copied this function from right up here, right? And so this function here, it's an anonymous function. It's going to take in, it's defined with two parameters, so it'll take in two arguments. It's going to give me an int, right? And then it's going to run this stuff. And now I need to execute this function. So I need to put the curly braces after the function. And this not the curly braces, but the parens. And this paren is the ending paren for the println function. And then I need to pass two values into this. So I'll pass 8 and 9 into that, right? And that's how I put that function inside of a print function, right? And then that would run. So right now this one gave us 8 right after hey, I'm anonymous. And if I run this again, this one's going to give us 17. And so now we have 17. And then sometimes you'll see people streamline this and they'll be like, okay, I just want this all on one line, and it'll look like this, right? And so that's what that could look like. And again, if you come back to this syntax, right, there's the func keyword, and then the receiver, and then the identifier, and then the parameters, and then the return, and then the code block, and then we have curly braces after it. where we pass in our arguments, if there are any, and that's how the function executes, right? Oh, okay, I could read that when you go through all that. All right, so I'm just going to take that one out there, but I just wanted to illustrate sort of like that concept there, because that one throws people for a loop when they first start to see it. And so here we have this closure. So closure is another thing that throws people for a loop when they're just getting exposed to it. So we're going to come down, particularly if they're learning JavaScript, we're going to come down here to number 9, closure, and we're going to see what closure looks like. And so the entire idea of closure is that functions are first-class citizens, so we could pass them as arguments. We could also, return them. And so here we have a function. Here's its identifier. It takes in no arguments, but here's its return. It's returning a function. And that's the type right there, right? It's an anonymous function with no parameters, and it has the return of an int, a value of type int as its return. So that's the type of that function. And so that's what's being returned. And here you can see that's what's being returned, right? Like that's the type of the function right there. And so if we were to do a printf %t, that's what we'd see. It's like this is a value of that type. It's a func that returns an int, anonymous func that returns an int. And so here is this function that we're returning, and we're defining this function to be count plus plus and then to return count. And we're defining the variable count out here. Well, just take a look at that, right? And so count is defined in the scope of clox, which is closure example, right? Count's defined in that scope. And then count is used in the scope of this function, which gets returned. And we're going to return that function, and then that function can be assigned to a variable. So we're going to come back up here, and we're going to call clox, and then that's going to assign a function to that variable, and then we're going to call that function. And when we call that function, right, this function here is closing over the count variable, and it's taking with it the count variable initialized to 0. Right? It's taking with it the count variable initialized to 0. So this function gets returned. All that stuff highlighted gets returned. It gets assigned to counter A, right? And it's also closed over that count variable. And so every time we execute that, it's like looking back, and this is just the way closure works in programming. It's looking back and it's saying, okay, I started working with count, right? And every time this is executed, it's going to increment count, because that's what the code does. It says count plus plus, add 1 to count. And so the first time we execute this, count goes up to, I'm just looking for where the code is, count goes up to 1. Second time, count goes up to 2. Third time we execute this, count goes up to 3. And so you can see that right here, 1, 2, 3, 1, 2, 3, 1, 2, 3. And then if we call clox again and assign it to another variable, counter B, and start executing that, every time we execute that, that's going to start over too, because when we assigned it here, the closure wrapping over count was a whole new instance, and so it started out at 0 again. That's closure. So closure, I think about it, it's enclosing another variable. It's taking that variable with it. I talk about it like that in the README, so you could go read the README if that's still a little bit foreign to you. So here we have an example of a method. So I created a type. So if we come down here, we're looking at number 10. So I created a type person, just like I started to do at the beginning, and then I created a method. So here's the receiver, and so it's attaching to any value which is of type person. Any value of type person, I will have this identifier, this variable p, and that's going to give me access to anything about type person, right? The struct type person. And so this receiver attaches that to anybody of type person, and attaches this function to any value of type person. And then you could call that function from a value of type person, and it'll print out their intro. And so their intro will be a string that they say when hello I am, it's how they complete that sentence. And so up here, I call that right here, I create a person, and that person's intro is going to be Bond, James Bond. And so when I have that person, I could call that method with dot notation. And there's that method, and it says, hello, I am Bond, James Bond. And then we have a sequential execution. What you see is what you get right here. And so this is just kind of interesting, right? But here we have n is equal to 42, and then we're assigning an anonymous function, and I put this all in one line. And so here's the identifier, here are the parameters, there's no return, here's the code block. It's just going to print out F11 because we're in example 11. This is function 11 for this example, and then it's going to print out that number. And so here's F11, right? And then I run F11, and n is 42, right? So it looks, F11 runs, and it looks to see what is the value of n. That's what F11 does. What is the value of n? I'm going to display that, and it displays 42. And I change the value of n to 43, and then F11 runs, and it looks, what's the value of n, right? And n is now 43, so it prints out 43. And so what you see is what you get. You kind of just have to logically read code sometimes. But this setup right here, you know, is a good illustration of sequential processing and sequential execution. And so that's what I meant to say, sequential execution. And so that's an example of that. And I point this out because one of the examples on the Ultimate Go tour over here, right? One of the examples over here. When you look at the examples here, we go into functions, and when you look at the different examples over here, or maybe it's one of the hands-on exercises, that little piece of knowledge I just gave you will help you understand the code. All right. And then we have multiple returns. And so here's so fun, count words. And let's open that up. So I'm going to grab that. I just want to make sure I don't run out of time here. And we have so fun. And so there's so fun, multiple returns. And this is fun, right? This one's just fun. And what this does is it opens up a file, which is all of the text for The Great Gatsby. And if there's an error, reading the file, it tells us there's an error. And we use defer to close that file. So when all of this is done, when count words is done, it's going to close the file so we don't leave open resources taking up memory on the computer. And then we create a new scanner, and we're going to scan all of the words and split on all the words. And then we create a counter, and we're going to scan over each of the words. And every time we scan over a word, we're going to count it. And if there are any errors with that, we're going to report it, and then we're going to print out the total words. And so, you know what? The Great Gatsby is only 48,000 words. That's kind of amazing. Pretty popular book, 48,000 words. And I don't know, Fitzgerald might have been able to retire on that. That's pretty cool. And so that's so fun. It's just fun. It's just seeing Go, some of the different things Go can do. And then we have Sugar here. And so Sugar, let's see what Sugar does. Sugar creates a user, syntactic Sugar, right? And then we have a factory function returning a user. And I don't need to return, like if this was production code, there's no reason to be moving into pointer semantics here, to be returning a pointer. But I just want to show you how pointers can automatically be dereferenced and how that's syntactic Sugar. And so down here I create a user, right? I get my user and I check for the error. And if there's an error, I just log fatal that there's an error, my program ends. Fatal means it ends. And then I print out the address of a struct, right? Because this returns a pointer to a user. And so I'm getting the address to a struct. So right here, you could see that when I print that out. And so where did I print out Sugar? So Sugar gets printed out right here in main, and then I'm using syntactic Sugar and run Sugar. And I'm using packages here, so you can look at how packages are set up. But when I print out here, you can see I have the address of a struct. That's what that's showing me. And then the type of that, when I look at the type, it's a pointer, right? It's a pointer to a user from the package syntactic Sugar. And then if I wanted to, I could dereference that pointer and I could say, give me the first name from it. But I could also just do this, right? And then this is the syntactic Sugar, is that you automatically, Go will automatically dereference your pointer for you when you have a struct. So you could just get to the fields. And syntactic Sugar is kind of cool. You could read about it in one of these, you know, deals right here. So I'm just going to look for that deal here. And so there's syntactic Sugar. It's convenience just to make your code cleaner and easier to read. But I just don't want you to be confused if you're like, wait, why didn't I have to dereference that first to get to the field? Because Go does it for you, just so your code is more readable and doesn't look crazy like this. So that's syntactic Sugar. All right, I'm going to pause the video again and look to see if there's anything else I want to mention. See you in a second. All right, just tucked the kids in. My daughter's got COVID, and that's where we're at. Yeah, wish it wasn't that way, but she's doing great. So things to go through here. We have named returns. So one of the things you can do is named returns. I'm not going to explain it because you shouldn't do it. And it's not idiomatic, nor does it make it's not idiomatic because it doesn't make very readable code. So one of the things I include in all these readmes is a code review check. And if you look at the code review check here, it says no named returns. Named returns decrease readability, and empty return is not idiomatic. That's more my opinion than it is something that I've seen as some straight out of the Go team or official Google doctrine. But that is my opinion, and I've also heard it be voiced by many other people who are really good with Go, not to do named returns. And you could find all of these code review checks here at the root of everything 000 BRBK, the root README, right? And here we have, I'll add no named returns here, but here are all the code review checks that you could read from all of them. They're all summarized. These are like the important things that you look for in a code review. Like if you're doing some of these, it'd be like, no, you're not supposed to do those things. So that's one thing I want to point out. Next thing I want to point out is closures. And so I thought this was a really nice description of a closure. So I'll just let you pause the video and read that, but really recommend reading that part. And then we have type error and error checking and returning errors. So this is all really good to read because checking errors and dealing with errors, it's a really important part of the Go programming language. And it ensures that your code has more integrity and is more robust. And so that's super good. And something that I just want to point out here is returning errors from functions here. So here we have errors new and just returning a string, right? So you could create an error like that and return it if you're returning an error from a function that you've created. And you can pause the video and just look at that and see how that makes sense. And then log fatal is also a really common way to sort of deal with errors if you don't mind just killing the program if there's an error. And so there's log fatal, and so that's like a common way. And this is like just so common in Go. If error is not equal to nil, right? Like I want to get a t-shirt that just has that on it. If error is not equal to nil, then anybody who's a Go developer and sees me wearing that t-shirt will know, hey, I am too. Here's that bit on syntactic sugar, and I thought this was a really nice description, so you can pause the video and take a look at that. And then also the last thing is the code review check, which is that one right there, and that sweet Hachiko dog. I'm not sure how you say that, but that reminds us of the defer function. All right, so if you want to learn more about Go, click this link and use this link here, because when you use this link here, it's like, a link to my course, the platform I sell it on. If you use the link that is linked here, it's got a code in it, and so that code's going to give you a better price, and it also gives me a larger percentage of the revenue since I referred you to my own course. So click that link here if you want to take my class. If you want to take Bill Kennedy's courses, you could click that link. I'm going to open in an incognito tab, and when you come in here, you could click have a discount coupon. You can enter my name, and you'll get a surprise discount. And if that discount's not enough for you to afford the course, you could go in here. They have a scholarship form, and you could click that link and fill it out. And so some people live in parts in the world where, there's just whole different economies. And so if that price is too much for you for the economy you're in, you could just say, hey, I could afford $10 a day, or I could afford $10 because that's the daily wage in the country I live in, or whatever. And you can tell that to Bill, filling out the scholarship form, and he'll probably just give you the course for free. So that's definitely worth checking out. Hope you like this. Leave a comment down below. Love hearing from people. And hit like and subscribe if you enjoyed it, and I'll see you next time.